this is chapter 8, question 19. Squids and octopuses propel themselves by expelling water. They do this by keeping water in a cavity and then suddenly contracting the cavity to force out the water through an opening. A 6.5 kilogram squid, including the water in the cavity at rest, suddenly sees a dangerous predator. If the squid has 1.75 kilograms of water in its cavity, at what speed must it expel this water suddenly to achieve a speed of 2.5 meters per second to escape the predator? So to start off, we have the total mass is equal to 6.5 kilograms. The mass of the water is equal to 1.75 kilograms. Therefore, the difference of those gives us the mass of the squid, which equals 4.75 kilograms. And the desired speed of the squid is 2.5 meters per second, and we need to know what speed must the water be expelled to allow the squid to reach that speed. So we'll start off with the momentum of the squid. So P squid equals mass times velocity, which equals 4.75 times 2.5 meters per second. And that gives us 11.875 kilogram meters per second. And according to the conservation of momentum, the addition of these two momentums, the momentum of the squid and the momentum of the water, should equal 0. So since the momentum of the squid equals 11.875, the momentum of the water must equal negative 11.875. From there, we can solve for the velocity of the water being expelled by dividing its momentum by the mass of the water. And that gives us negative 6.78 meters per second. So it's 6.78 meters per second in the direction opposite of the squid. Question B. How much kinetic energy does the squid create by this maneuver? So kinetic energy, the total kinetic energy is equal to the kinetic energy of the squid plus the kinetic energy of the water, which equals 1/2 mass times velocity squared of the squid plus 1/2 mass times velocity squared of the water. So that gives us 1/2 times 4.75 times 2.5 squared plus 1/2 times 1.75 times negative 6.78 squared, which gives us 14.84 joules for the squid plus 40.29 joules for the water. Since the negative velocity is squared, it's positive. The total kinetic energy is equal to 55.13